Okay, I guess we're live now.
Yes. Okay. Sure. Let's go.
Thank you for being here. This is quite a short notice, actually. So Jahanzeb is actually on a 20 hours transit from Pakistan to Germany.
No, to Austria, to Vienna.
To Austria. Oh,
Yeah, yeah.
You do your research
Yeah.
as part of your university in Vienna. Okay.
Not really Vienna, but TU Graz in Graz. So that is like 2 hours away from Vienna.
Okay, that's a name that I don't know.
So Graz, Graz. Yeah.
Wow. Okay.
Mm-hmm.
So thank you very much again for being here with me because I've always wanted to know more about your research sort of story, because I know that you're one of those guys who have been able to find your way around the whole academia side of things, the publishing side of things. How does this whole sort of process work? What does it mean? What's the significance of anything in this whole process? And so going back to our nest days together, I think there is a lot that has happened. In fact, me and Jahanzeb are meeting for the first time after 6 years.
Actually, after NAST, right? So
yeah, so 2017 was the last time we saw each other, and today is the first time we are seeing each other again. So thank you again, and I totally appreciate the time you're taking out of your 20 hours transit to be here with me. Okay, so let's start this off. I'm personally very much interested in knowing what is it that you've been doing for the past 2 years, and how did you get there? So for my benefit, if you can tell me what is it exactly that you have been doing for the past 2 years, and then how did you get there? Like what was your journey of getting there?
Yeah, I mean, first of all, thanks a lot for having me, and I'm very happy to be here to talking to you. And
my pleasure.
Yeah, so I mean, condensing everything into 2 years would be a little bit difficult, but I can first start by what I have been specifically doing in the first 2 years, and that's basically research. In short, right? That's the overall answer I can give it to you. But more specifically, I've been doing my research in the field of computer vision. So that is, I would say, as I tell it to people, is making machines see. And by making machines see is that we want to emulate the human perception system. So with humans, it's pretty straightforward, because we are being inbuilt with the processes of processing things or visual information, for example, or language, or whatever modalities you can think of, touch even. But when you're talking about machines, then it's a little bit tricky because machines can, of course, you can give sight to a machine. For example, you can have a camera system which can feed some information to your computer, but then the computer has to process that visual information, or that data, or that language source, and take out the useful aspects from that, right?
Yeah.
So
sorry to cut you, but one of the ways I used to explain it to my students in the AI class is that if you showed a picture of a classroom to a computer, the computer will be able to tell you that, hey, there is a chair, there is a table, there is a teacher, there are students, this is a wall, this is a blackboard. But to go from that level for a computer, to go from that level to tell you that, hey, this is a classroom where the teacher is actually teaching the students something, that kind of contextualization is, I guess, the problem that you're working on.
I would say I would even go to a little bit lower level here, okay. Right? So as I see it, computers cannot really tell you that there are chairs, there are stuff inside this okay. Visual data, right? Even for a computer to tell you that there are different aspects inside this one image. The computer needs to understand this image, and this is what we call this semantic understanding, right?
Interesting.
So the computer needs to have an understanding of this scene, and then it can tell you that there is a chair, that there is a I don't know, a car.
Yeah,
I mean,
yeah.
This is an absurd example, but I'm just giving you this overview of computer vision, for example.
Yeah. So what were you trying the cars, like what were you trying to get the cars see? Like were you trying to detect something? Were you trying to understand a scenario or a situation, traffic, other cars?
Yeah. So one of my research goals, or one of my primary research objectives, is autonomous driving.
Oh, okay.
Yeah. And with autonomous driving, I have this niche which I'm particularly targeting, which is making present day object detectors. I can just give you one example of an object detection system. So object detection is basically or object detection is one field in computer vision where you have to kind of classify. So when you're given an image where, for example, Junaid is there, right, and there is a car, right? So this object detector has to first classify and say that there is Junaid and there is a car, right? But then it also has to give us the exact location, so it has to localize as well, right?
Oh, okay.
So this is kind of this other subfield than image classification. Image classification is a more general problem which is being studied in computer vision, for example, which is basically just concerned with telling what is the object which is present inside this image, and there's no localization. So this object detection is kind of a more fine-grained problem, I would say.
Wow.
Yeah.
I really want to ask more questions on this front because this is a personal area of interest for me. Mm-hmm. But I want to go back to the original sort of question where I want to know, how did you get to that place? So how did you get to research these things before actually talking about the research?
I would say I've been immensely lucky. So
is that because you worked hard, or is that just because you?
I mean, I do not particularly come from a computer science field.
I know that.
Yeah. So I've been studying electrical engineering during my masters in Pakistan. So I did my bachelor's in electrical engineering, and there we weren't really given an introduction towards deep learning or machine learning. Okay, we had one introductory course, but that was pretty much it, right? So I wouldn't really call it hands-on deep learning, machine learning stuff, right? But even during that period of time, I had this, I don't know, you can call it epiphany or whatever you can imagine, that I really wanted to know what exactly was deep learning, what exactly was machine learning back then, but I didn't really know how to get into this, right? So, and I'll be 100% honest, I didn't really put too much effort during my bachelor days to get into this particular topic, right? Then fast forward, I mean, I would again say I was kind of lucky to get into an engineering school in Germany. I applied. In fact, I only applied to a single engineering school in Germany, which was KIT in Karlsruhe. So Karlsruhe Institute of Technology, and there, I mean, since I had done a bachelor's in electrical engineering, so again I did a master's in electrical engineering and information technology. Nothing to do with computer vision, deep learning, but as I said, I got a little bit lucky. I had I always wanted to know about computer vision, machine vision, what was happening. So there was this one course which I took, and it just blew my mind basically. So I was like, yeah, I mean, this is something which I really want to know.
In what way? Like
I would say, I mean, it was kind of an introductory course that what can present day deep learning systems, or what can present day computer vision systems actually achieve, right?
Oh, okay.
And it was kind of building up the basics of what are the basics of computer vision, basically, right? And so I took that. I didn't do really well in that course, I would say, but that's another story.
Did you pass?
Of course I did. That's how I completed my master's, right? So I did that basically, and this was kind of my entry into the field. So as I often call it, it's kind of a taking different courses and figuring out stuff. If I know what I know now, I would have chosen a completely different path during my bachelor's. So
Wow.
I would never have done electrical engineering, basically. So
what would you have taken?
I would definitely have taken computer science.
That's actually the same for me as well. You know what's funny? When I got my admission to NUST, I wanted to get into software engineering, but that was 2013. Software engineering was not the thing to be in.
Exactly.
Mechanical engineering was the thing to be in, and so I spoke to my parents. I spoke to other sort of advisors, uncles, people that we were in touch with, and everyone said, "Oh no, software is like the lowest of the merit, and you should get into mechanical engineering because that's where most of the opportunities are, X, Y, and Z, and whatnot." And lo and behold, 2 years later, I'm regretting. I was actually in Sheikhupura in the Atlas Honda manufacturing plant, and I realized at that point, because our supervisor in the engine manufacturing plant said anything that was to be done was done by the Japanese, anything that will need to be done will be done by the Japanese. All you have to make sure is that the machines should run properly. And so that really was the watershed moment for me to say, hey, maybe mechanical engineering is not for me and I need to pay more attention to software engineering. I was getting admission in NUST in software engineering without any sort of so basically on the national sort of selection seat, I chose to go for mechanical engineering on the international seat. So I paid extra. I did not achieve anything of the I paid extra. I did not achieve any of the sort of benefits of doing a mechanical engineering, and I haven't looked back. Like ever since after that point, after graduation, I switched into software development, and I think that has been the direction that I've been constantly growing in.
Yeah, I mean, this is kind of a little bit of a detour into the Pakistani education system, or how do we choose a degree in the end? That's not always the smartest way to do it, I would say, right? But again, that is a little bit of a detour. I like to talk about that, but maybe we can come up.
We can definitely skip that. I don't think there is any winners in that debate. How did you go from the master's to the PhD program? Starting from where I left. So I had this course and I really liked it, right? And I thought maybe I need to probe into this a little bit further, right? Then I was searching for an internship. So at our university, we were required to have an internship at some industry before we could graduate, right? And there were specific credit hours which were assigned to that particular thing, right? Yeah. So I was searching for an internship. Again, I would say, I got a little bit lucky. I got a little bit lucky. Again, I applied to one position at some good tech firm, and I got in. Basically, I was doing some programming stuff there. I was working with Python. I was working with some. That was my first real introduction to Python. I would say. And that's already at the end of my master's, right? So that was the first time you got exposed to the world of programming. Exactly. I had some programming experience. For example, we were taught C and C++, I think, during our bachelor's. But I didn't really look into it closely. I wish I had. In hindsight, everything looks a little bit more clearer. But anyway, so I was, but this was this first place where I was hands-on, working on a project and stuff, right? Then my first internship ended. I switched to another team, and in this other team, they were doing autonomous driving stuff. Wow. And I just had an interview with them, and I just told them that I had this background with deep learning, with computer vision, which was only this one course, by the way. Don't put it on her. No, it's okay.
I got this 3 months internship, the second one at this tech firm, and that was kind of this game changer in this whole scenario, I would say.
Interesting.
Because the first internship was more working with this platform applications and stuff like that, right? But this was more hands-on research experience, which I got, and this was So in those 3 months, I was working with some basic computer vision stuff, and I really liked that, and that was, I think, C++.
Wow.
So it was pretty nice.
So you went from Python to C++ in what's the time frame that we are talking about? Because that's quite a substantial jump.
These are like 9 months, right?
Wow.
But I would say my advisors in this second internship were really nice people, and they were really supportive. That I didn't know the basics, so I had to move around, and there were a couple of co-workers with me who were always there to help me, and so they were pretty good at programming.
That's excellent. One of the earliest computer programming assignments that one of our how in bachelor's we used to have computer programming, and then we used to have computer programming lab timing. So one of the assignments that we got during the lab timing was ask the user to enter 4 digits, and then the program should sort the 4 digits using an algorithm. And it was C++. And the interesting thing is, I did not know what an algorithm is. And so I asked the user to input 4 digits, and I split the string into 4 digits. And then I went on to hard code if A is greater than B, and then if B is greater than C. What ended up happening was I created a 784 line or something program in C++. And the best part about that is that it worked on the first try, because there was no way I could have debugged it if it didn't work. It was all copied. It was all copied and pasted, and because it took me such a long time, I was the last one to leave the lab that day. But my friends were all waiting for me because everybody had done the program in 2 lines, but using bubble sort and quicksort and all of that.
Exactly. Yeah.
I was the only one who had 800 lines of code. That was C++, and that is still one of my memories for the initial days of using programming. So
I mean, I could imagine. As we were talking earlier, when you were asking me that how good are you at some programming language, I would say not good, but I can get the work done.
Get stuff done. I think that is what matters. That is what matters.
At the end of the day, we are both engineers, right? And engineers always would like to get stuff done.
Exactly. I am actually very happy about the fact that I went into engineering, regardless of the fact that it's a mechanical engineering or any other kind of engineering, because ultimately I believe that the engineering degree basically teaches you how to deal with an imperfect
that's true
system. And I think that can be applied, or that skill can be transferred to any sort of
as I often talk to my advisor currently, and also my postdoc and stuff. I mean, a PhD cannot really make you the perfect computer scientist ever. But a PhD program can give you the skills which are transferable, right? And by transferable skills, I mean, I don't know, it can teach you to look at things very closely, right? And it doesn't have to be computer science only. Then you can apply it to any other field of life. Basically, can if I can be as general as that, right? And whenever you look at a problem or some basic problem at your home, you would always be thinking more deeply into that particular problem, and this is something which at the end of the day PhD is really good at teaching you, I feel. So coming back, so I had this internship. It was pretty nice experience, right? And then there was this I had to do a master thesis, right? And so at that particular team, they were not really working with deep learning stuff, but they were more focused on some low level computer vision, basic trajectory estimation and stuff like that, right? But they were not really working hands on with deep learning. So I asked them for a master thesis, and they were offering me the stuff which I was doing during my 3 months internship, which made sense, right?
Yeah.
but I basically told them that I really want to do some deep learning stuff, and I want to know about AI and all this in the autonomous driving domain. So I had my master thesis on kind of evaluating different object detectors and different state of the art deep networks which are used for detecting objects in the 2D and 3D domain in adverse weather conditions, right? So it was just basically running a lot of object detectors, taking them, and then having this different weather data, or this adverse weather data in fog, rain, and snow, and trying to find this breaking point where exactly do these object detectors or deep networks break, right?
Interesting.
So I did that, and it went pretty well. And then later on, I just started. This was the time where I didn't really plan that I would be doing a PhD later on. So even during my master thesis, I didn't really think that I would be doing a PhD. But at some point, I think 5 or 6 months in my master thesis, I was like, I've only scratched the surface. I've done a master's thesis. It's going good, and I feel that I would get a good grade and stuff, which also happened. But I still felt like I'm just scratching the surface. I don't really know enough, right? But I was also very much afraid of starting a PhD in this particular, because my background is just not that, right?
Yeah.
So I just talked to an academic friend of mine. He's good at this academic stuff. I know it. I know it for a fact. And I just talked to him, and I was just discussing stuff, and he was like, "Man, you should do a PhD." He was. This was something which was the very first thing or very first time I had been told that I could do a PhD. There is this huge mental block which you have for nothing, basically, right? But somebody needs to just clear that. Somebody just needs to. He probably didn't really understand what exactly I was doing at that time, right? Later on, we wrote a paper together at one of the best conferences, and it got through and everything. And now he's really good at this stuff because we were working on a project together. But at that particular time, he didn't really understand this deep learning stuff and this. But he kind of saw something where he told that maybe I have this mental capacity to kind of take on a PhD, right? And this was the first time when I heard that, and then I just started applying at PhD programs. So so this was like kind of I often call it, I forced myself into.
Sorry to cut you, but so you applied for PhD positions.
Yes, exactly.
You did not get offered one.
No. So I had one talk with the professor at KIT, where I was actually doing my master thesis. I had a talk with him, and the talk went really well. But later on there were some funding issues. So but the professor really liked my profile, like how I went about things, because I had done a master thesis with him, of course. So but then it didn't really work out later on. But then I was searching for different positions. I was applying at different places, and that is how I found my current advisor.
Interesting.
So I was so there was this job posting, and I knew his a couple of his works beforehand. He had been working with the tracking, object tracking and stuff in his days. I would say in his research days. So I just applied, and then I just got an interview call, and then it worked out pretty nicely.
Wow. Okay. Because I was under the impression that maybe through the work that you've already done, maybe someone reached out to you for the PhD program that you actually took part in. And I find that interesting because the fact that you've actually gone through an application process, I am actually very interested in understanding more about that. How does that work? How do you go about like finding a professor? I'm a total noob. So for example, if I have a proposal and I want to take it to a few professors and I want to apply for a PhD program or get funding or X, Y, Z and whatnot, what should you think about when putting together that application? What are the most important factors in that?
Yes. So basically, first of all, or one of the most important things is that you need to have a background in that particular field, right?
Yeah.
So you cannot expect to get a PhD in mechanical engineering when you've been studying computer science, for example, right? So I mean, this is like the most basic stuff, right? Second of all, I mean, I would say you need to have a clear idea of what exactly do you want to do, right? Because I can specifically recall one question in my during my interview. So my current PhD advisor basically, I mean, he had a couple of projects, right? Or maybe he was just testing me that how adamant or how hell-bent I am to get a PhD in computer vision, right? So he had a couple of projects. One was on computer vision, which was using or which is this current project which I'm working on with this representation learning or unsupervised representation learning. But there was this other project which was more applying deep learning techniques for signal processing or stuff like that, right? So there was this one question which clearly stands out. So he asked me that would you be interested in that particular project. So but I was pretty clear that I want to do something with computer vision and not with signal processing, right? I told him no, I'm not really interested in that, you know. So
interesting.
So this is something which I feel you need to have a clear idea of what exactly do you want to do, right?
Yeah.
And this is one of the most important things. And then there are other things that you need to have a background in it. You need to show that you have been already doing some projects on your own. You know, this is really important, I feel, because a PhD journey is very lonely, let's say, right? So you are given a wall and then you have to take that wall down, right?
Yeah.
And there is nobody who is going to really help you take that wall down, right? So professors are always looking for people who can work on an individual level, right? And not just taking a lot of input or I don't know, working as a coding monkey or something. I mean, that's a really bad term, but
okay. The whole sphere of professors working in universities, running their own labs, this whole sphere is a big giant mystery box for me. Help me understand what goes on here. Who is a professor? What do they do? What's their role in the overall process? What are they looking for? Why are they looking for such? Just talk to me a little bit more about. Explain it to me like I'm 5 years old.
Sorry. So I mean, this is actually a good question. So I mean, as I see it, I mean, I'm not a professor, so I can only give you an opinion from the outside, right? So there are different kinds of professors in different parts of the world, I would say. Specifically, I can talk about Europe here because I've been more involved with professors inside of the EU. These professors are basically getting funded from the industry, right? And there are some industrial projects. For example, there would be a car manufacturing company who wants to kind of collaborate with the academic sphere and try to get the research from the academic sphere and then try to kind of apply that research into their particular products, right? So a professor is basically overlooking the entire process, right? A professor would bring in the industrial collaborations, and that means basically money to fund the lab, right? And then with that particular with that amount of money, he would actually hire people like me to work on on some projects, which would eventually go on to help the industry, right? So, okay, I mean, research is fundamental. Research is like looking into new stuff, but at the end of the day, you also need to apply it somewhere. If the research is not going to be applied anywhere, so what's the point?
This actually fits right into the next question that I had in mind. Is the work that you're doing, how does it get translated into, or how does it go upstairs? I would say upstairs because I'm picturing research at the super granular level, sort of your. You mean
this low level fundamental stuff, right?
Fundamental stuff. Yeah. How does it get translated into the upper levels of industry? How does it get commercialized? Who does it? For example, the object detection that you have worked on, this research, how will it find its way into a car that maybe I'm driving someday?
So I mean, first of all, research would take time, right? So the stuff which I'm kind of doing right now, it would probably take a lot of time to get implemented into an eventual car, right? But what happens is that I am working closely with the car manufacturer, right? So the funding is partially coming from the car manufacturer and partially from another project, right? So which is a research project. So I have this collaboration with this car manufacturer. They give us some requirements that we should be looking into this particular area, right? We look into this particular area and open up new research directions, right? And then we kind of propose something starts to work. We also have to kind of do our own research work or complete our own requirements of a PhD. We write a publication, for example, on this. And then we also have this non-disclosure agreement going on with our industrial partners, right? So this research is exclusively done to help them in their particular product, right? So we are doing this fundamental stuff, and then this is taken with our help by the industrial partners, where there are engineers, where there are scientists, maybe even working and trying to kind of take this particular fundamental research and put and try to kind of have this prototyping done, right? That maybe even if it works or not, right? And then they would have this prototyping done. They would kind of try to implement this stuff there, right? And so they would test it out, but that is kind of their hands-on job, right? There could also be more PhD students who are actually doing it for them, because they could have more collaborations, right? Yeah. So this kind of is like, this is how you kind of close this loop, right? So you have this fundamental stuff, the industry takes it, but they have the power to kind of visualize it into an actual car, because they're working on that, right? So that is kind of how the chain of command goes.
So if I'm a company and I want to commission your lab or your people to conduct some research, what will be the KPIs for that funding? So what do you need to do that will be that will be basically the deliverable for the research that you've done? Is your deliverable just putting out and publishing a paper, or are there any more ways that the funding is basically structured in how it's paid out, when it's paid out? How does that whole thing work?
I would say publication is one part of this whole spectrum, right? So by writing a publication, we kind of show that our work is kind of accepted by the community, right? And it has some value to it, right? And by displaying this value, we are actually telling people, or let's say in this case industrial partners, that you could actually take this because this has already been peer reviewed or has been looked upon by some other people in the field who are experts, right? And this has a chance to kind of work, right? So publication, I would say, is just one part of this whole spectrum, right? So this is not the main goal. But coming back to your question, so what is kind of these requirements which are being given to us by the industry? So these are some requirements which are kind of agreed upon before even starting the project. So for example, my advisor or my postdoc or whoever writes this grant proposal would have a higher level overview of what exactly can they offer to the industry, right? Yeah. So they would write this whole research proposal. They would say that we have this background in this, and how exactly can our research in the future help you, right? Because research is more talking what can happen in the future. So nobody is really certain that it would work out or not work out. So there has to be kind of a trust between the industry and the academia that whatever people are saying would actually hopefully materialize one day. But it could also happen that it just turns out to be a dead end. And that's also okay. That's also research, in my opinion, right?
Yeah.
So my advisor or my professor has this overall broader overview of this whole project. He writes a proposal, and then this proposal is kind of looked by the industry. That does it really help them in any way?
So generally, what does it look like in terms of deliverables? Like, do you say that? So if I want to write a proposal today, what would I generally look for in terms of pitching? Do I say something to the tune of, you are going to learn X, Y, and Z about this problem that you're facing, or we are going to help formulate a solution to this problem, whatever? Like, generally, what does that look like, the proposal?
So so generally the proposal would be general as well, right?
Yeah.
So in research you cannot be really specific, because you cannot say that I'm going to build an autonomous driving car by 2025. Some people have done that, and let's not go into that, but
they're regretting it now.
So there is no such thing as surety, I feel, in research, right? So this research proposal would be more connecting what this research group has done before. For example, they have worked on autonomous driving before, and they have solved this problem, right? And then you kind of show that we have this experience, we have the people cut for the roles, right? And they could actually help you later on in your particular products, right? But you do not really say that this is something which would be done, or this is something which you kind of give this holistic or this overall picture that this is something which we would be looking into this because we have the expertise to look into this, right? And then the industry has to decide that this really useful for them or not.
That's very interesting, and that brings me to the next question, which is, I'm not an academia person, but I hear that professors have a very difficult time securing funding for different projects. The first question is how easy it is to get funding. If you're a professor, especially at a good institution or a good lab, how easy is it to get funding? But B, which is I think my more the question that I'm more looking forward to, is how many problems do you see these companies have? Are we writing all the proposals that should be written, or are we focusing on a very narrow subset of proposals in general and leaving out 80% of the problems on the table with nobody looking at them?
So let's just start with the second question, right? Because I forgot your first question.
Sure.
So going to the second question. I mean, this is actually an interesting question. So I think while doing research, we are also actively finding problems. So there are problems existing which we don't even know about, right? So while working on something, we would actually find out 10 different problems, right? 10 more problems, right? And then we work on those problems, right? So this is how kind of research goes, right? So nobody actually really knows exactly all the problems which are being faced in autonomous driving, for example, right? So we are kind of looking into so these systems are kind of failing in this particular scenario. So we test those systems in those scenarios, we show that it fails, and then we kind of propose or try to propose a solution, right? But then, we propose a solution, it's okay, but then we find some problems in those solutions, and then we kind of move into that direction, and then in that direction, and then in that direction. So I feel there is no red line into this. So there's always this zigzag path which goes towards finding more problems and creating more research opportunities, I feel, right? But at the end of the day, I feel research is not like there is a hard deadline or this hard end line inside. So you just have to move around and try to see.
I guess what I'm trying to ask here is, if we have 10 universities and 10 car manufacturers, and all the universities are writing proposals for autonomous driving and object detection and trying to make the autonomous systems better, chances are that maybe their wheel rotation problems are not getting looked at. So what I'm trying to ask here is, when it comes to computer science, the spectrum of problems that car manufacturing companies or other companies are having, there must be other problems that companies are having or they are trying to improve compared to autonomous driving. Is there a sense of these are the highly marketed, interesting, bling areas that a lot of researchers sort of write proposals for, and which leads to higher competition? But on the flip side, if you are looking for a project on doing something with the car regenerative braking, that is something where there's a lot less competition. Does that dynamic exist where there are areas or problems with super low competition, there are other areas with super high competition? Does that dynamic exist?
Of course. Yeah. I mean, as in every other field, I feel academia is also very, very competitive, right? So, and securing funding is a very, very important part of academia, and it's definitely not an easy part of academia, right? So I feel it definitely exists, and I also feel that people would be kind of looking into this very niche kind of problems, or and maybe too much focus is being put on those particular problems, and maybe we are also leaving out very important problems, which we just call them out of scope or something in academia, right? So I do feel this is happening, but I also feel, and I also, as I previously said, that in academia or in research, you're also kind of actively finding new problems at hand, right? This all goes hand in hand. But you are right. I feel.
So you've already sort of answered my first question, which is how difficult it is for professors to bring in the funding, or like how
very difficult, I think. I mean, I'm not I'm not really a professor myself, but I could really see it in the industry or in academia, that professors have a really, really competitive environment, right? So and they really need to be on top of their game to kind of secure some funding, because as I see it, research can be, and I also said it previously, that research can be a dead end, right? And nobody really wants to put in money into a dead end, right? And research cannot also give you money tomorrow. Research might give you prospects of money 10 years down the line or something, right? So the companies are kind of more careful, I feel, in putting in the money, right? So I feel this is kind of a, how do you say it? I mean, I cannot really blame them, but
you have to look at both sides of the
I cannot really blame them, but also I cannot really, I mean, being an academic, being a researcher, I also feel that this is kind of harsh on the research community, that you have to fight so much for doing basic research. I mean, at the end of the day, researchers are trying to help you, right? It might not just give you the benefits tomorrow, but
exactly. I personally am in the favor of it being competitive, because I think academia being competitive is the best filter that we have to avoid the dead ends and put money to good use, because that competition sort of creates that dynamic where it naturally incentivizes selection of problems that we believe are actually solvable. Would you agree with that?
Yes, to an extent. I would say there should be some competition, because otherwise, you don't want to make the game too easy, right?
I mean, like, I'm just picturing that if we had to put money on something, yes, figuring out how to clean up our oceans should definitely be a priority compared to researching whether mermaids exist or not. You get what I mean? So I think competition naturally creates that sort of a spectrum of where we need to focus and what we need to prioritize.
I mean, I would agree that competition is also healthy, right?
Yeah.
But I would also be in favor of companies and industry taking a leap sometimes, taking this leap of faith, right? As I call it.
Do they? Like, do companies take a leap of faith? Apart from some government institutions or non-profits?
To be 100% honest, I feel the trend is downwards now.
Okay.
All these big labs, I feel they're really cutting more and more from the research domain. I mean, right now it's not really a good time for tech anyway, right?
Yeah.
So the trend is kind of downwards, right? And this is why I feel that there should be more incentives for researchers and for research. I feel in general.
Yeah. Coming to professors, what are the characteristics of a good professor? If I am looking for a professor as an applicant, what should I be looking for?
Yeah, this is one of the most important questions which I kind of wanted to talk about, but I wasn't sure if you would naturally get to that, right? But because this can maybe just help somebody who is trying to find some professor, right? I would say never go after the big names,
Oh, okay.
So I would back the statement up, right? So I would say always look for compassionate people, and by compassionate people I mean people who are kind of you have a couple of meetings with them during your interview phase, right? And you also talk to their lab mates and stuff, and try to see that how is this person, right? And you need to find an advisor who would be how do you say it, looking after your back, right? So when you fall down, right, that is where your advisor has to pick you up, right? Rather than finding an advisor who would slide you down further, because there are advisors, there are people. I mean, stuff goes around. So there are actually people who are how do you say it? I mean, I don't really want to say that, but there are some professors who are kind of notorious in this particular aspect, right? Who would demand too much of them.
I hope the audience is getting what I'm sensing here. What you're actually trying to say.
Yeah. So I mean, the bottom line is that I would always choose a professor who is compassionate.
Yeah.
I wouldn't just look at the big name, right? And by big name I mean having, I don't know, millions of citations, for example, right? I wouldn't really. I mean, yes, that is an important part, right? That can probably help you later on much more in your life, right? But during your PhD, right? I mean, if you don't get a PhD, then there is no later on, right?
Yeah.
So for kind of choosing this advisor, I always advise or I always tell people to find people who they find compassionate. That is the bottom line. Who would really look after you when you are down, when you don't have stuff going for you, right? When you are stuck on a project for 2 years and then you kind of hit a dead end. So it's the role of the advisor to kind of pick you up at that particular point, right? Rather than putting or playing this blame game, right?
Yeah.
In this aspect, I feel I was particularly lucky again to find my current advisor, who is super nice. He
amazing.
he is a good name. He is a well-known name in the academic sphere, in the computer vision sphere. But he's also one of the most humble guys I've ever really
Amazing.
met. So so this would be my advice to anybody who is kind of finding an advisor.
Is the information about a lab's funding public, or like can I find out how much funding this professor has been able to close, or is that a non-public
Not really.
data?
Not
or
really.
Does that even matter for me as an applicant to a particular professor, or?
I think not. I mean, so professors usually have this web page on which they kind of advertise that you should. I mean, if you're looking for a PhD position, you should apply, or you should apply through this channel, or email me directly, or whatever. So whenever you find this basically means that they have the funding, right?
Okay.
I mean, I would also say that while doing a PhD, it's. I mean, you should have this talk very upfront with your advisor, that does he have the funding for the entirety of your PhD or not, right?
Okay.
By entirety, I mean, you kind of have this rough estimate that it would take 3 to 4 years or 4 to 5 years or whatever, right? I feel this is kind of really important. And why do I say it is important? It's simply because of the fact that you don't want to focus on research and writing grant proposals. That's really too much, right? I mean, PhD is itself a huge task and a very intensive task, right? So choose an advisor who would kind of give you this overview that things are good at my lab financially and stuff like that. But I mean, coming back to your question, are they public? Would anybody advertise on their webpage, for example, that I have funding for this? I mean, that's a little bit too fine-grained. I think that wouldn't be.
I think you answered my question, which was primarily how do I find out if the funding is available or no.
Mm-hmm.
If we exclude the professors that are the million citations people or the celebrities, if we exclude the labs that are the celebrity labs or the labs that keep on appearing in media and stuff, for example, MIT Media Lab, such where thousands and hundreds of thousands of people could be applying for. If we go out of these and we look at the rest of the academia, do you think more professors are looking for people, or more people are applying for less number of opportunities?
I mean,
how competitive is it?
Are you specifically talking about my field? Because I can only kind of answer.
Yeah, for sure. I mean, whatever you have seen and whatever impression you have. So if I'm not looking at a super high tier level, but I want to get a decent, respectable PhD, is it super competitive to find a good professor, or is it more of a task of going around doing my research, finding the right person?
I would say again there is a difference of mindset between the EU, between Europe, and between the North America or USA particularly, right? There I feel in USA there have been many horror stories going on these days, that it's becoming very competitive. So basically you need to have a PhD in order to get enrolled into a PhD program, right? So
interesting.
That's funny, but but I mean, I've been following some social media posts where people have been kind of saying that these are the quality of applicants which they are kind of receiving, right? And I mean, it basically sounds absurd that they have all these major publications to show off even before they kind of get into this program of a PhD, and some are even from an undergraduate degree, right? So in the US you can actually start your PhD right after your undergraduate degree. So you have this extended period where you have to take these courses and stuff, and later on, but that's different in the EU. So I mean, there have been some cases where, a person has like 3 or 4 or 5 even major publications during the undergraduate level, and that's really, really making the playing field, I would say, very competitive, so to say, right? But when we are talking about the EU, it's a little bit less, I would say, but still, I mean, it is a very, very competitive time to get into computer vision, to get into deep learning, or to find a good lab for that particular matter, right? So you will have to kind of talk to a lot of people. You will have to, go to conferences, for example, if you're lucky enough, and talk to people or talk to professors there, show your research to them. And conferences are the best place to find professors, I would say. You go to, even if you do not have a paper in a conference, you can still go to a conference just to kind of look at the field, try to meet people, maybe you get a good match, right? So it's basically just, looking around, talking to people, and then trying to find the best match out of all that. But it's definitely getting more and more competitive, even in the EU now.
Yeah. Jahanzeb, tell me, what makes a successful PhD? Like, how do I know that my PhD program has been a success?
Okay, so I mean, again, I'm not a PhD yet. Hopefully, I might get it one day. But it's going okay. So that is something which I can tell you. So I feel for doing a successful PhD or trying to do a successful PhD, first of all, I mean, you need to be curious, right?
Yeah.
You need to have this. You need to have this curiosity which is always burning inside your brain, right? You need to find things and look at things closely, right?
Yeah.
And that can only happen when you are interested in the project or in the topic which you are, of course, doing your PhD in, right? Otherwise, do not start a PhD. And another important thing which I kind of always tell to people who are trying to kind of ask me that do we do a PhD or not. I always tell them that when you have a long day, right? At the end of the day, sit down and think about a PhD program and ask yourself this simple question: do you want to do a PhD program, or do you want to do a PhD? I mean, if there is even a slight doubt in your answer, that maybe or whatever, right? Yeah. And even if you are not answering yes with conviction, do not do a PhD at all. Because PhD can be really, really tough. It is actually a very, very lonely journey, as I also mentioned before, right? So you're on your own. You are doing your stuff. You are sitting in your lab, and then you have to figure it out what is happening with something.
How do you keep yourself motivated, and how do you keep your focus on what's important?
Yes, this is actually an important question for people who are probably going to start their PhD soon, right? So I feel it is really, really important to have a bigger picture in mind.
Yeah.
This is something which I really talk about a lot with people who are kind of applying to PhD programs, that you need to have this end goal in mind, or this bigger picture in mind, that what exactly do you want to achieve with your PhD, right? Okay. And another thing is that you need to be curious and stuff like that. But a very, very important part is taking care of your personal well-being, right? And with personal well-being, I mean that you would have to spend countless hours in front of your computer anyway, right? So try to come up with things which can actually interest you, other than your PhD program. Try to start a hobby. Try to do sports, for example, right? Try to indulge yourself into activities which can keep your mind refreshed, and because there should always be something other than work which really interests you. Otherwise, you will get burned out very, very quickly, I feel.
I remember when we first met at Nust, you did not look like how you are today. And
don't show a picture, man.
I might as well. But I still remember how we went on a summer break and you came back totally different. And I believe you started running. Are you still running, and how has that affected your life?
I link a lot of the good things in my life to running, basically. So I used to be a fat kid from the time I can actually remember, right? And I mean, it's okay. You can be fat if you like it. You can be fat. I have nothing against it. But at one point, I really did not like it, right? And that's also okay to not like being fat for yourself. I mean, you should not body shame anybody, but you can, of course, like and not like for stuff for yourself. So that was kind of an epiphany, right? For example, as I really like to call it. So so I go to my summer break, and then I had this one goal in my mind that I want to shed this much of weight, right? And I had been a sportsman all my life. I had been playing cricket. I had been playing badminton regularly, but it wasn't really helping me, right? Somebody told me, and that is my father, right? That I need to get into get into running. I remember the first day I ran 3 kilometers. I cramped myself up. I could not walk. Then I later had to play badminton. I cramped myself the second time. And even my father thought that, okay, this was a one-time thing, and he would never do it again, right? But I came back 2-3 days later, and then I just started running. I just built it up, right? So day after day, small steps. I took all these small steps, and then by the time I knew it, in 3 months, I was down around 20 to 25 kgs.
Wow.
Yes, and that was, I had to control my diet and stuff and this and that. But the thing is that this again gave me this confidence in life that I can do whatever I want to do or whatever I put my mind to, right? And this is actually a very, very big thing to have this inside of you. True. that you can actually achieve whatever stuff you want to, right? And this is something which has been kind of driving me throughout my PhD journey as well. That the only key to success is consistency, as I see it. So of course, with consistency, you need to work hard, but you need to work hard consistently, right? By one of my advisors in one of my internships always told me that when you have to build a huge wall, you cannot really build the whole wall at once. You have to put it brick by brick, right? And this is basically just saying that you have to be consistent over a long period of time to achieve something, right?
True.
And this has transpired in every field of life for me, and it has worked wonders. So even during my PhD, right? I have this how do you say it? I have this marathoner mentality that I'm in it for the long haul. I'm in it for suffering, right? But as with any marathon, after 42 kilometers, the suffering will end, right? The same is with PhD. The suffering will at one time end.
That's awesome.
Yeah. So
that's awesome. That's very powerful.
Running has helped me in so many different ways. I have a huge training schedule now. I'm also working towards a triathlon. So hopefully next year I do a triathlon. I've actually already completed my summer goal, which was a duathlon, which was this 60 kilometers of biking and then and then a half marathon. So and I cramped up twice in that particular in that particular adventure as well.
Okay, so now publications. What are publications? What is their significance? How do they work? How do you publish one? And again, give me the explain it like I'm five version.
Okay, interesting. So, publication is basically just a piece of written manuscript, which you write after, when you have to present your research to somebody, right? So you do this research inside a lab. You spend countless hours. I don't know. Let's say 12 hours in a day for 6 years, for 6 months or something, right? And you have this very very deeper understanding of the research topic which you are researching on, right? And then what happens is that ultimately you get some breakthrough in your research topic, right? And then the next step is that you have to present this breakthrough to people who are or present it to a broader audience, right? And that is basically what a manuscript or a publication or writing a publication is, right?
Okay.
This is basically just called a manuscript. So you write it up. So you have this technical document, and where you are basically presenting your research, right? And coming back to the second question, what exactly is the significance of this document? So, as I see it, publications are very significant because this is something where researchers have to kind of showcase what exactly have they done, right? And what are their insights into this particular problem. Because you can sit inside your lab for 10 years, and if you do not really tell anybody that what have you been working on, right? Then it's basically in a way, I wouldn't call it useless. Of course, it's still useful, but you have to kind of put it out to a broader audience, just to kind of get this feedback, and just in the hope that you will actually be kind of encouraging more people to work on this particular topic, because this is how research works. You do something, and then you kind of hope that some other geniuses would catch on to your work and make it much better, right? So this is kind of this chain of improvements.
Have you ever watched Mythbusters?
No.
Okay, so Mythbusters was this super popular show on Discovery Channel run by Adam Savage and the other guy I don't even remember.
Okay. Mm-hmm.
It's my bad,
yeah.
but he was equally as important. And Adam Savage, who was the host, he used to say the only difference between doing science and messing around is writing it down. Is that true for what a research paper actually is? Like,
I would say there is some truth to it.
Right? There is some truth to it?
There is some truth to it.
Because every time I hear about a research publication, I basically go back to, Adam Savage said, science and messing around, writing it down. That is what
I would say research and science. This and messing around. They all go hand in hand in a way. Because when you're doing research, you're not doing old stuff because you want to do something new.
Stuff.
And when you have to do something new, you have to mess around with things. You have to play around with this knob, with this knob, with this knob, whatever is kind of working. Let's say, right? So then this is the messing around phase, right?
Yeah.
And then when you have messed it around, right, then you kind of have to put it up, right, and show it to other people.
And so how do you go about publishing it? Do you just like publish it on your own website or blog, or do you need someone else to publish it?
Basically, the thing is that I can also publish it on my website or blog or whatever, right? Whichever platform do we have. But ultimately we want other people to kind of see our research, right? And we want a broader audience for that, right? Yeah. And one of the simplest ways is that you write up your manuscript or your research document, right? And then you send it to a conference, right?
Okay.
And you send it to a conference, and then usually the conference is peer reviewed. And by peer reviewed, I basically mean that other people like me or you who are in the field and actively researching in the field would be kind of looking into your research document and try to kind of come up with strengths and weaknesses. Is it worthy of getting published into this particular conference or not, for example, right?
Interesting.
And then, I mean, this is basically just to kind of have this mechanism where other people are also kind of agreeing on your point of view, right? Then you have that, and then ultimately the conference publishes it, and the main benefit you get is that you have a broader audience in the end.
So are these conferences special type of conferences, or are they just the normal everyday conferences that we just hear about? Like,
what exactly? I mean, can you?
So, I mean, there is a large technology conference going on here in Dubai over the next month, but I don't see any PhDs here. So what I'm trying to ask here is, the conferences that you are talking about, what do they look like? Who organizes them? Where do I find more about those conferences? Are there any internal announcements? Where are those conferences hosted?
Yeah. I mean, every research field has its own particular conferences, right?
Okay.
So it's not like there is this one big conference where signal processing is also published there, where humanities stuff is also published there, where computer science is also published there, where electrical engineering is also published. No, it doesn't really happen like that.
Oh, okay.
So there are these, so for example, I work in computer science, right? So there would be some specific conferences on my particular topic. So I'm not even going to general computer science conferences, because there is no general computer science conference, right? There would be, for example, computer vision conferences where I'm more interested in. But then there would be probably some other conferences where you kind of I'm not 100% sure, but maybe you discuss programming languages or try to make them better or something like that, right? But I don't really go into that. But I go into my particular topic, which is computer vision, right? And that also holds for all other subfields inside of science, for example.
True. And if people support your paper in a conference, does that have like any official demarcation to it? Like, is there like an official recommendation that goes out? What happens in a conference?
So as I said, so you send your paper to this to this conference. I mean, coming back to the other question which I missed. So these conferences are kind of organized by independent bodies, right? And some well-known researchers usually kind of get together, and they kind of have this platform in which people put out their research and send your research documents to this particular conference, and then these are peer reviewed. 3 or 4 people, independent people, look at your research document and try to judge it, right? And after judging it, they kind of give you, I shouldn't really say it, stamp of approval, because at the end of the day, I feel 3 or 4 people cannot really judge your research in the best possible way, right? But it still is better than nothing.
Can we call it that these 3 or 4 people give it a sense check?
Sanity check, yes.
Sanity
exactly.
check.
Yes,
okay.
yes. So I would say that they can give it a sanity check. And then you are invited to a conference. You have to go there. You have to present your paper, for example, and then at a conference, you have this bigger audience, right?
Okay.
So it can happen that some big conferences, for example, have even 10,000 paper submissions, right?
Oh wow!
Only in computer vision, for example, right? And there is this conference this year which had 15,000 paper submissions, right? So that's really crazy to think of, right? So after a certain number of papers get in, right, and then some certain specific authors are kind of invited to present their papers. There is no real restriction that who can attend a conference. So even people who do not really have papers can also go there, right? Yeah. But you would mostly see the authors who are going there, right, to present their own work. Then you have your presentation slot or whatever you call it, and then there would be a huge audience from multiple different backgrounds, right? in computer vision, not everybody is working on the same topic as well, right?
Yeah.
There's like hundreds of different fields, subfields, where people are different, looking at different things in a different manner, right? So so you kind of open, or these conferences give you a platform to open your research, right? And then by opening your research, you kind of invite other people, right? And then those other people come to you, talk to you, attend your presentations, try to see if it's valuable, not valuable, or give you feedback, or have some talks.
Very cool.
Which can also get heated at times.
Are there like debates?
Yes, I mean debates, as in there have been some debates as well. There have been some heated arguments between some well-known researchers, which are well documented as well, which I can
drama.
Basically, but mostly these are very constructive feedback loops, which you kind of get, I mean, conference is basically a way to generate feedback loop.
Very cool.
Right? So it's like it's a pretty nice experience, I would say. So,
what are citations?
Mm-hmm. So,
why are they important?
In academia, these hold a certain value, right? Citations are basically, so after you have a paper published, right? How do you? I mean, this is a kind of a difficult question, I feel, because the merit of a paper is not only or should not only be judged by the number of citations it gets, right? But still, it is one metric which can be used to kind of judge the significance of a paper, right? So once I write a paper, I put it to a conference, I present it, then maybe some people find it useful, some people build on top of that, right? And when they build on top of that, they would hopefully cite my work, because they kind of got an inspiration from my work, or they explicitly used something or some idea from my paper, and then build on top of that, right? So they would cite me, and this is also, I would say, a constant feedback loop again, right? So you put out a paper, and then you see that how well is the community accepting your research in general, right? So in some sense, I would say it can give you a picture of how impactful your work is, but I wouldn't really, put a hard line that this is the only metric which can give you this feeling of impactfulness.
Are these calculated automatically, or is there a body that actually counts the citations? Or
I mean, there are. I mean, these are automated systems. For example, Google Scholar, right? So
that is what I'm pointing to.
Yeah, exactly. So Google Scholar can just. I mean, it indexes all your papers on your own profile. So every academic can build his own profile, and then so the papers are automatically indexed. So whenever a conference is kind of putting its proceedings online, so Google Scholar will automatically index it, right, onto your page. And then whenever somebody is citing you, it's a very good system, right? It's a very huge, complex system, in my opinion.
Very, 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 very cool. I had another question on citations, but okay. Major publications. What is a major publication? How do we know if something is a major publication or not?
Again, this is. I mean, we are again going into these subjective debates, right? People have different views of what is a major publication, what is a minor publication, what is this, what is that, right? Long and short, I can give you one example, or the only answer which I have to that is basically that conferences have a ranking. Right?
Okay.
So some conferences are A*. You can go to I forgot the name of this website, which basically ranks or can give you rankings of different conference venues. So basically, you can go to this website, type a name, and it would tell you that is it an A* conference, is it an A conference, is it a B conference, is it a C conference, or
wow, I didn't know that.
So these are yeah. So these are kind of different grades which are being put. I would not comment that are these grades highlighting the impact of this conference or not. That is again a very subjective debate. All these ranking systems are kind of, that's, I'm not here to really comment on anything, right? But in my particular field, what do we call a major publication is basically a paper or a publication which is being published at one of those A* venues, right?
Okay.
So that would be like, you have a paper at an A* venue, then you kind of call it a major publication. I don't really like the name of major and minor publications simply because research doesn't work like that. Nothing is major, nothing is minor. Everything is important, I feel.
So I actually remembered my question on citations. When I look at a paper and I look at a citation, and I'll give you an analogy. So when I look at a car and I see that it has 300 horsepower, and I know that majority of the cars in the market, the good sports car, are roughly about the 700 mark. The top end models are 2000, 1500 horsepower. The lower end cars are 100 horsepower. When I look at citations, when I look at research papers, how should I calibrate my mind? What amounts to a good average number of citations for a good impact? Is that 200, 1000, 5000? And then like give me that benchmark. If a particular paper has more citations than that, then I can tell myself at least that probably this research paper is a very impactful research paper. Or no, the other way.
There is really no answer to that, I feel.
Okay.
The thing is that sometimes in my particular field, some papers can really blow up. For example, in the age which we are living in, which is this, fancy X or Twitter or whatever it's called now. It's called X, right?
Yeah.
So, there is a huge community of computer scientists there who are working on computer vision. So, there are some people who have a huge following there, right?
Yeah.
Maybe somebody is liking one of the papers from this one particular venue, right? Or this one published paper. He puts it up, right? This paper blows up. This paper invites traction or has a lot of traction in the research community.
Yeah.
People really know about this and then start to cite it, right? And then there could be an equally good paper, which it can happen that many people missed, right?
Yeah.
And maybe these big accounts who have a huge following missed it, right? They could not really post it or whatever happened, right? And maybe there are some researches which, just go under the radar, but are really, really super nice researches, right?
Yeah.
So this is why I say that the citation count is one metric, which is not the perfect metric, but of course it has some value in some sense, right? So when you are doing research and you want to find impactful research, there is no real other way than to kind of dig deeper into.
Let me push back a little bit on that. And this is a friendly challenge. So who is better? There is a professor or a researcher who has worked hard to develop an audience, and for the sake of making my point or making my argument, that researcher ended up writing a mediocre paper, but because of the work that he has done to develop an audience, he's able to market that research to a huge number of people, and maybe 100,000 people are actually able to read that research, compared to another professor who might be a superstar at his work, but that researcher may not be a good person. People may not like him, and nobody ends up reading his research paper in this hypothetical scenario. And the research paper might be the next Einstein's theory of relativity, whatever. In your opinion, does that element of publicity matter for a researcher, or it shouldn't matter?
It does.
Yeah.
It does matter, I feel, but it shouldn't.
Yeah.
I mean,
yeah.
As I said, people have given different names to different papers. Some are minor, some are major. I don't really. I don't really want to categorize research in that particular way, right? So
I get your point.
Yeah.
What are some career paths, like for a person to think about PhD? How do you link doing a PhD research with career? Where can you land after doing an impactful amount of research? Where do you land from there into the industry?
So the question is that what are the career paths after doing a PhD, right? So I mean, there are two main career paths. There is no real. It's a no-brainer. So one is the industry and one is the academia. You have to choose one of them, right? So a PhD, as I said, teaches you some specific set of skills which are valuable for both of these. Right. So if you are going to the academia, there is a huge chance that you would be successful in that. And even if you choose industry, you are kind of going to be good in that as well, right? So I feel this is also very very subject specific. So in my particular domain, I would say PhDs have a lot more freedom to choose what they want to do later on, right?
I see.
So you would never say they are overqualified for a job. So you would never say that if they choose industry, then they are overqualified.
Yeah.
Right. And of course, I mean, if they choose academia, then that is the natural progression which you can get after doing a PhD. When you're talking about different research fields, then you kind of tend to think that academics would always be in academia, right?
Yeah.
But my particular research field, deep learning, AI, computer vision, I mean, it has opened this these things which are very unique, I would say, which probably wouldn't be the case in I don't know, some fields like, I don't know, humanities maybe, I don't know. I'm not 100% sure, but it could happen, right? But in my particular field, if you have a PhD, you are very much qualified to have a very impactful job in the industry as well.
Okay.
Right. And of course, I mean, if you want to stay in academia, then that is the natural progression.
Yeah. So I'm a person who has 12 years of development experience, and you are a PhD. I might be more suited for positions that are in the product management or the product lifecycle or project management or maybe development, DevOps, X, Y, and Z, whatnot. For a person like you who is coming from PhD sort of route, with the background that you have, give me an example of what kind of a role can a person like you play in a large organization, say for example Apple. Like what will your role look for an organization like Apple or Tesla or any one of these large organizations? What will you be doing?
I mean, I would specifically be looking for positions which are research oriented. So there would be research scientist positions, right?
Okay.
And the companies which you mentioned actually made my life easier to answer this question because these companies have a huge focus on cutting edge research, right? So they're not really just making one product and trying to live off that for the rest of their life cycle, but they're actually trying to innovate as time is going on, right?
Yeah.
So when you have this kind of a company, for example, you talk about Meta, you talk about Google, you talk about I don't know, Tesla, for example.
Yeah.
Then these companies are actually trying to become better and better every day, right?
Yeah.
And the only way to become better and better every day is to find new directions,
exactly.
right? And the only way to find new directions is to hire academics, right? Which can provide you with these new directions, right? So I would be looking at, for example, research scientist positions.
And are these positions good paying positions, or like are these senior positions, or?
I mean, these are very, very well paid positions.
Okay.
I can definitely answer that. So the research positions at these big industrial labs are pretty nice.
Okay. Are we talking any ballpark number? Like,
Yeah, I mean,
Have you seen any ballpark numbers or any impressive numbers?
I mean, I've seen 1.5 million.
Wow. For what?
A year. So dollars.
For what?
Yeah. For I mean, the person, or I mean, yeah. I don't really want to go into specifics, but I've seen a research position offering that. Yes.
I mean, what kind of a role basically?
I mean, that's a little bit more senior role, I would say, right?
It's a lot of money.
That's a lot of money, but yeah, exactly. That's a lot of money.
Wow. We are almost at the end of our conversation. Just last few questions that I'm personally interested in. What is the state of autonomous cars? So earlier we were talking about my BMW, and it had that system where it was able to detect the lane. It was able to keep the car in the lane, but I could sense the shortcomings of that system where it wouldn't necessarily detect something on the hard shoulder. So it wasn't very super, like the front corners, they were sort of a blind spot. If anything were to be in those sort of corners, it would start failing down. Whether it would work actually very well in fog, because a radar can penetrate through fog, and so I could see if there is a car in front of me or not through the radar. But the vision system wouldn't work. And then similarly for rain. Tell me, what's the state of autonomous cars these days? Are they actually good as what Tesla or other companies might be saying, or are there more shortcomings than the ordinary public is aware of? How are these systems like comparing to each other?
Yeah, without naming names, right? I would say
we're talking about the science here.
Yeah. Without naming names, I would say the industry is definitely blown up currently at its current stage. So the people who are actively researching in the field know that there are a lot of shortcomings right now. Right?
Okay.
So, I mean, for example, you just mentioned one of the leading companies which tries to make self-driving cars, right? And which is focusing more or less on the vision system, as far as I remember, right? So by vision, I mean camera systems, right? And they're very adamant that they would make autonomous driving work with camera systems only, right? But I mean, according to my research as well, this is not really, I mean,
the best way.
I don't really want to put a hard sentence, for example, on this, that it's not really the best way, or
would you say that LiDAR is better than cameras?
No, I wouldn't say anything is better than anything.
Okay.
But I would say I'm definitely a huge fan of multimodality, right?
Yeah.
So I'm a huge fan of multimodal systems, combination of systems, for example, right? So I would even put radar into the mix, right?
Yeah.
Because there would be some scenarios in which some of these modalities would fail, and there would be some scenarios in which other modalities would fail, right?
I see.
So when you have this abundance of information, right, then if you are able to mix it together perfectly, right, then you could probably have this mixture of experts, or whatever you call it, right, and then you can take the good of all worlds, let's say, right, and then if you are able to find this system which can perfectly combine these things together, or these data modalities together, then I feel that would be the way forward, right?
I see.
But currently, as we are speaking right now, I mean, this is like a very intense and an ongoing area of research, right?
Yeah.
And that is one of the reasons why I say that the field is a little bit blown up in some sense.
Do you see autonomous cars a reality over the next 5 years, 10 years?
I cannot give you an exact timeline, as some people do, but I can definitely say that I do see them as a reality.
Yeah.
Yes, I do.
Do you think our infrastructure is ready for that? let's assume for countries that are actually pioneering these technologies, do you think the research, the infrastructure is actually ready for?
I do.
Yeah?
I do.
Okay.
I mean, I mean, even if it's not ready for the system, they will make it ready.
Okay. And can technologies like vehicle to X, vehicle to vehicle, can those technologies make an impact on autonomous driving as well, or?
They will.
Yeah.
They will. I really feel, and I am a person who is a strong believer that we need to have as much information as possible, right?
Yeah.
And I talked about the multimodality systems, right? Multimodal systems. And then this also comes with more, vehicle to vehicle communication, vehicle to X communication. Then this also means that my ego vehicle or the vehicle in which I'm going in has more information, right?
Yeah.
Basically. So multimodality and all these different names which you just mentioned, I think they would play a huge role going forward.
For sure. Jahanzeb, it's been an amazing time speaking to you. I didn't even realize that it's actually been 1.5 hours.
Oh, really?
There is so much more that we can talk about, but I think for today, let's call it a day before we actually dive into more in-depth topics. Because I believe we have a short period of time, and I have to show you Dubai as well.
I'm looking forward to it as well. Yeah.
Thank you so much.
Thanks a lot. Thanks a lot for having me, and it was a pleasure.
Likewise. It was actually a very good learning experience for me.
Oh, I'm glad. I could offer you something.
Thank you so much.
You're welcome.
Thank you so much.
Yeah. Bye.
Bye.